We have our next speaker, Anya Bida. Anya is a senior member of technical staff at Salesforce, where I used to work before Databricks. She's also a co-organizer of the San Francisco Big Analytics Meetup group and is always looking for ways to make the platforms more cost-efficient and secure and obviously scalable. Previously, Anya worked at Alpine Data, where she focused on Spark operations. So let's welcome Anya.
So again, I'm Anya, I'm an SRE, and I'm going to give you some perspective on failure. So first I'll tell you about me, and then what I do at Salesforce, and then we'll get into the talk. My preferred pronouns are she and her. I'm on the production engineering team at Salesforce. I support Salesforce Einstein, which you might have heard about. It's awesome. I also organize the SF Big Analytics Meetup. We love meetups. Come and talk to me if you're interested about that. And I've given some talks on Spark tuning, so I'll give you the slides later. You can click on those and check them out. I have degrees from schools, and I have worked at companies. So at Salesforce, we're obsessed with customers, and just want to give you kind of an idea of the scale that we're interested in and how we're using Spark there. So we think that we're right in the middle of the fourth industrial revolution. You think about industrial revolutions around like steam and electricity and computing. Well, now we think intelligence is the fourth industrial revolution, and we're going to use intelligence to make our customer experiences awesome in ways that they have come to now expect. And one of the ways we do that, we serve predictions. This is around Salesforce Einstein. We're serving up, lots of predictions every day. And this is actually some really hard stuff using Optimus Prime and automating a lot of the grunt work that data scientists do so that they can do more interesting stuff. So if you're curious about that, I can talk about that later. Okay, so today's talk, this is just enough DevOps for data scientists. And I'm correct that there are no DevOps people in the room. Okay. So part one of this talk I gave at Scale by the Bay, a conference a while back. Part two here, I'm going to just focus on DevOps as applied to Spark. So I'm kind of gearing this talk towards my introductory data scientist intern who wants to come and run their jobs, but they keep running into failures. So we'll talk about that. But first, what is DevOps? So I think about DevOps as kind of like the intersection between lots of fields. Infrastructure and release, build and release, network and security, and software development. So probably you might find yourself more on the software development side. Maybe you're at a startup and you wear all of these hats. Or maybe you're just totally out of the picture. Well, DevOps is really the intersection of all these fields. And so we kind of, that term SRE was coined at Google, and so we kind of live with the developers and with the operations folks, and we kind of form that bridge to make everything run in production. Is anybody running, everybody's using Spark, most people are using Spark. Who's running Spark in production? Okay, so a few people, awesome, very cool. Okay, so I'm gonna kind of gear this talk towards my data scientist intern, who I'm gonna call Ada, at our Women in Tech meetup, because Ada is awesome. And so hello, Ada. Where does she fit in? She's probably not in any of one of these circles, right? But as a data scientist, you depend on infrastructure. You depend on your SRE and your DevOps team for pretty much everything, right? So I guess, I don't know if I have to give this slide to this particular audience, but a Spark primer, I always give this, I always talk about this slide in all of my talks. We know Spark consists of, we got the driver program, and the driver is the brain, and it's going to launch executors. And I always like to remind people that on each executor, we just have, the executors are running on actual machines, and those machines sometimes die, right? So on those executors, it's just a container. It's simply a container. It's got some cores, it's got some memory, and the tasks are going to run on those executors. So just so that we're all on the same page. Great. So let's go back to Ada, and she wants to run her favorite example, the word count. We love it. Awesome. I know. Can we have something else, please? Next time you're up. Okay. Awesome. So I'm going to go through this word count job and just highlight all of the failures that you should expect when you're running on commodity hardware. And raise your hand if you're not running your jobs on commodity hardware. Okay, I didn't think so. So we're going to expect to find a lot of failures, and we're going to talk about some best practices to overcome those common failures so that you can do more interesting data science-y stuff, right? Okay, so Ada runs her word count job that she got from the Apache Spark website. And it runs great the first time, right? And then the next time she runs it, there's a failure right in the first line. What? I've got a failure when I'm just trying to read from HDFS. What? I don't want to know. I don't want to know about failures. I just want success here. So let's talk about why this might happen. So first off, I'm trying to read from HDFS. Let's talk about my HDFS cluster. Is it reliable? So let's think about blue-green deployments. Maybe is anybody here familiar with that concept? Okay, a couple, awesome. So I'm running my word count job and it's running successfully on my blue HDFS cluster. Maybe this is my name node, my blue machine, and it's running successfully. But, oh my gosh, we need to do a kernel update. Or for some reason, that blue machine needs to go down. My SRE team decided, oh gosh, it's gotta go down, or it went down on its own because it's commodity hardware. So existing jobs should be maintained on that old blue machine, but on the new green machine, new jobs, new Spark jobs, new word count jobs should route to the new machine, right? So I've got my new name node that should accept all my new jobs. So here I just want to make the point that you should use high availability with your name node. So that's the first kind of tip in my very simple word count job. Also, make sure you've got plenty of disk space for HDFS. It's very simple, these things, right? Also just to point out, disk space on each disk is different than disk space on HDFS. So you're all familiar with that. Yes, awesome, good. You don't know how many times I come into the problem where there's plenty of disk space on the cluster, but there's one particular machine that has all of the disk taken up, right? So those are things that your SRE team would monitor and would be alerting on and would hopefully handle before your jobs start to fail. Great. Okay. Also, your SRE team or your DevOps team, or maybe you, will be monitoring your disk I/O and your network connectivity and really making sure that you have the right permissions. Maybe your job failed because your team changed the permissions on that particular HDFS file, right? So your job used to run, but it doesn't run anymore.
To your point, there's a very large sock provider that doesn't officially support HDFS, so they have a non-zero probability of the data getting corrupted.
Oh.
If you use HDFS, they want you to use it.
Yeah, HDFS is definitely not the only storage system in town, for sure. Okay, so let's get back to our word count. On each line of code, I'm just going to walk through and just identify what's going on here. Here I've got my Spark context, so that defines the Spark application, right? I've also got all of these operations. And if I look in my Spark web UI, I can see this really nice DAG that shows me all these different operations and what's happening there. Each dot represents a different RDD, so that's really handy. I can see which RDD has been saved for reuse based on the color of that dot, right? Let's see. I've also got, in my beautiful DAG, I've got these stage boundaries. And how do we define a stage boundary? So looking at my word count, I can see that there's a wide transformation there, right? So this reduce by key is going to define my stage boundary. So if you've ever wondered looking at your DAG, wait, why are the stages defined as they are? Well, when I do a shuffle on a wide transformation, I'm going to Spark will create a new stage for me. Okay, cool. So just to kind of summarize what I said so far, I like to think about this in terms of dependencies. So I like to think about, at the top level, my Spark session, or my Spark application, is dependent on everything below. So the application depends on all the jobs, and then that job would depend on all the stages that are included in that job, right? And each stage has a particular set of tasks that it's dependent on. So when you find failures on a particular task, right, that might affect the stage and the job. So that's kind of helpful to just conceptualize when you come across failures. Also wanted to point out, like, how is an action defined? So, I'm sorry, how is a job defined? The job boundary is defined by the actions, right? So you're all familiar with Spark is very lazy, and once you come across an action, that's going to actually define the boundary of the job. So just helpful to conceptualize when you come across failures. And as we said, the Y transformations define the boundary of the stage, and the tasks are then that one computation to evaluate that one partition. And so you might have way more tasks than partitions, because you might have several task failures. And when a task fails, let's try again. So I might have hundreds more tasks than partitions, and so that would be why. Does that make sense? Cool. So going back to my DAG, where are my tasks? I don't see them in this particular picture. So in your Spark Web UI, there's gorgeous diagrams of the stages and how long they take and how much time is spent in reading and writing and compute. Fabulous. But what I want to point out is that the tasks, again, they're running on containers. So when you see task failures, it might be because the CPU on that particular core ran out. There was a high load, right? Or when you see that message, container failed, or failed to launch container, maybe there wasn't enough resources to launch that container on your cluster, right? So Spark is really tolerant to failures when, if like one of the worker nodes crashes. Spark is very tolerant to that failure. What if a couple of worker nodes crash? Fine. As long as your worker nodes are running in an auto-scaling group or in some, I have to be cloud provider agnostic, as long as your worker nodes are running in such a way that they can auto-scale, Spark is going to handle that just fine. And as of Spark 2.2, even if there's a particular disk, one disk on one particular node, Spark can handle that failure as well. Even if you're running on commodity hardware that doesn't have RAID, right? What happens when you've got a task running on a particular node, and that node becomes sick, it's out of sorts, right? There's a special case there's a special case. Let's say the executors keep failing on this particular node, say the top node. The executors keep failing. That node looks like it's available to Spark, right? So the next executor that comes along, oh, let's launch it on that particular node. It looks available, right? So that can cause this kind of repeated failure. In that case, you want to think about using the blacklist configuration. So search your Spark config for the blacklist parameters. And you can say, I want to blacklist that top node. Don't send jobs there for a particular period of time. So that's pretty handy. So just the point here is that tasks are running on executors. It's just containers, right? So there's a million reasons that you might come across task failures, right? But if I had to summarize the big ones, make sure you're just using your default retry and exponential backoff settings. Exponential backoff is the concept if I do some task, if I do some call, and it's failing, it might be failing because of a good reason. So let me not retry again immediately. Let me back off. Let me retry after 5 seconds, after 10 seconds. And so exponentially back off. Oh, and there I just repeated the concepts that Spark is really tolerant to several different types of failure. Enjoy that. Tasks a lot of times will fail because of your partition number is not optimized, or you've got data skew or some serialization error. So any number of reasons why tasks could fail. But the point I want to make here is that your stages are dependent on the tasks, right? And the jobs are dependent on the stages. So when you see failures, think about that dependency kind of layering.
Does Spark necessarily think that all the executors are homogeneous? Is there any kind of differentiation between the way it distributes computation across stages?
I like the question. So the question was, is there any difference in the way that Spark distributes the computation among the executors? So, well, just from the standpoint of the data is going to be partitioned, and each task is going to run on one partition. So you might have one partition that's much bigger than the others, right? So in that sense, the toll on that particular executor is going to be greater than on an executor that is doing its tasks on a smaller partition of the data.
In terms of
Oh, can the hardware be different? So I can create my Spark cluster with lots of different types of hardware. I could create using this machine that's optimized for memory and this other machine that's optimized for compute, and Spark can send those executor containers to every machine on the system. So in that sense, the cluster manager is really going to ascertain how many resources are available on a particular node, and then how many executors to launch on that node, as well as which job, the executors of which job to launch on which node. So from the resource allocation standpoint, the cluster manager is going to help you with that. So Yarn, Mesos, your standalone cluster manager, is going to help you decide, is going to automatically decide which executors to launch on which nodes. Cool. Okay. So let's talk about the shuffle next. So we're back here on our word count job, and we're doing a shuffle on the reduce by key. And we all know that shuffles sometimes can be problematic. This is where you get your out of memory errors. The shuffle is happening when the child partitions are dependent on an unknown number of parent partitions. Okay, so all of that data needs to be shuffled and maybe brought back to the driver, right? So the shuffle is intensive operation that causes failures frequently. So we all know we have to try to minimize our shuffles, but you can't like avoid them altogether, right? Okay. So when I'm thinking about failure, and I'm thinking about my shuffle, I want to think about RDD Re-use. So here I need to consider, should I save my RDD for reuse, or is it more efficient to just recompute that whole RDD from the beginning? And if I won't read this whole slide for you. I compiled this from one of Holden's books, High Performance Spark. Very handy. If I want to improve fault tolerance, I'm going to checkpoint. If I need to think about improving performance, I'm going to think about persisting. Does that make sense? So let's say I want to, I'm worried that my executors are getting decommissioned. Somebody's running crazy jobs on my cluster, and my executors keep getting decommissioned. I'm going to think about, okay, I need my RDD to be available even if that executor is decommissioned. So I'm going to go over here and say, I want a checkpoint. Great. I want a checkpoint to stable disk, stable storage, whether that's HDFS or S3 or whatever storage you want. But I'm going to checkpoint to stable storage in that case. And this way, when my cluster is going crazy and the executors can fail for unknown reasons, I'm going to save my RDD in that way. Okay, cool. Oh, the other thing is, if your lineage graph is getting really complicated and really long, you could checkpoint to say, oh, I don't need this whole history, this whole very complicated lineage graph. I'm going to go ahead and checkpoint, and I don't want to preserve my lineage graph in that case. I want to make it shorter so that the recompute doesn't take so long. So the decision of whether I'm going to checkpoint or persist, it really depends on how long it would take to recompute my RDD. Cool. So just to hammer that home, persist to improve speed, checkpoint to improve fault tolerance. Cool. And then lastly, let's talk about the write. So save as text file. We counted our words. We want to write them. Okay. So this word count example is very small, but as you go and take your jobs into production, you're going to be doing some maybe counting larger files of words or other interesting jobs. When you do this, try to remember that reading and writing is not efficient. It's not efficient for Spark or for any distributed system. So let's try to minimize that. What you can do is think about writing a few large files instead of thousands of small files. Okay, it's just more efficient that way. Cool. And then the other thing, if you are writing to S3, anybody who likes to write to S3, just a couple of notes there. S3 has partitions. These partitions are not the same as Spark partitions. And these S3 partitions are not the same as HDFS partitions. So, and S3 partitions, they are your friend. Okay, it's just how S3 works. But partitioning can cause delays when you try to write to S3. So if you're writing a lot of small files, which many of you are doing, I'm sure, just know that partitioning can happen if you do too many S3 write operations in a short time span. So what can you do about this? Aside from writing fewer files, the S3 partitioning depends on the first few characters of your path inside your bucket. So hash it, hash that. Basically, put a few random characters at the beginning of your path, and your S3 partitioning is just going to be so much more efficient. And you can go ahead and write your many files in a more efficient way. So that's a pretty handy trick for the write step of our word count. And then all the same HDFS considerations apply, right? Okay, so what have we done so far? We basically came across lots of common failures in our word count job. And with these best practices, hopefully, we've eliminated the most common failures. And now Ada can go and do some interesting data science work, which I'm not going to talk about. I should mention that you need metrics and logging. So aside from the Spark Web UI, which is great, there's also some other tools. Ganglia is free. Use it. You can do dashboarding and windowing and say how many of my resources were used. Let's compare some parameters. Very handy. Also, the Spark History Server. Did you know you can persist your Spark History Server even after your cluster is terminated? Super handy. So that it's a really handy web interface to say, oh, this is my application, click. This is the logs from my particular application. And let me see the standard out in the same way that I'm used to seeing it when I'm running my Spark job. So this actually can persist after your Spark cluster is terminated. So save your money, use the Spark History Server in that way. Cool. So if you want more information about what I've talked about, if you are an intern data scientist and you want to learn more, aside from High Performance Spark, which I totally recommend, check out SRE. It's a site reliability engineering book from Google, so they coined the term. Really great conceptual ideas for running an SRE team, or if you're the person who runs the data at your company and you need to be a data scientist, this is helpful for just handling the SRE type work. Also, chaos engineering. You might have heard about this. It's a really great framework to conceptualize running experiments on your system and saying, what happens if I inject some latency? Might my word count job fail sometimes? And just trying to understand like how your system responds to those types of failures or almost failures that could happen in your system. So with chaos engineering, you kind of define your metric. I'm going to run my word count job, every minute and see how fast it runs, or whatever metric, how fast, how efficient, how many resources it's using, right? So you're going to have that metric, and then you define an experiment. If I kill a few nodes, what do I think will happen, right? You're defining your experiment, you're hypothesizing. And then you run your experiment, hopefully not in your production system at first. And then you kind of, the way I like to think about it, you could devise like a game day where you have maybe your dev infrastructure, your dev environment, and you run your experiments, and then you monitor, how does my word count job respond when my HDFS cluster has no disk on one of the nodes, right? So super handy. Nora Jones is one of the authors of Chaos Engineering of this book, so check that out. Let's see. Oh, and that's it. I don't have anything else to say other than thank you so much. I'll be here for questions. Is it still on? Cool. Are there any questions? Go for it.
You have good ways, like so people at your organization, for example, ask, hey, can you tell me how much my Spark job, how much my Spark job is using, or how can I optimize it more? Me, I want to point them to metrics, but I don't have any sense. Like history server with GUI, so.
Right. Sure. So the question was, somebody wants to know, somebody wants to quantify how much memory, for example, that the Spark job is taking, and how do I build that dashboard? So I would say the first thing that comes to mind is is your job running in a particular queue so that it doesn't take all the memory of the entire cluster? Might be one question. But JStat is a really handy tool, free and open source, for collecting all these types of metrics. I'm trying not to mention anything that you have to pay for. But yeah, Ganglia is very handy. So you can like configure your Ganglia dashboard and then run your jobs repeatedly, and schedule your jobs at defined intervals. And yeah, I'm not sure with Ganglia, but I assume that you can tag your jobs and see, okay, with Ganglia, everything that has this tag, how many resources is it using? So that's where I would start. Oh, all the cloud providers have like those dashboarding tools built in as well. I am using all the right words, yes. Sure. So S3 is this really cool tool, but it the partitioning. So S3 partitions your data in all your buckets the same way as it partitions everybody's data in everybody's buckets, right? And the partitioning, I have not yet, and I don't think it exists. I don't think there exists a way to view what is in a particular partition, because that's behind the scenes. But what I do know is that the way S3 partitions your bucket, it says, I want to take everything in this particular path and put it in one partition. And that first character, right after the bucket name, the first character in the bucket path, is how S3 is going to determine which partition to put your data in. So this comes into play. Let's say I've got all my files organized by customer. And I say customer 1, bucket customer 1, and then bucket customer 2. Well, if customer 1 has tons of files, customer 1's path is all going to be in one partition. But you don't really want that. You want all of the thousands of files in customer 1's bucket to be partitioned evenly, even among your other customers, if that makes sense. Yes. Yes. The reads and writes are, partitioning helps S3 to parallelize the reads and writes. Yes. Okay, maybe one last question? Or do we have time or no? Okay.
Just to add to that, are you sure it actually based on the first character? It could be based on the last character.
This is what they tell me. And it works when I do the hash, so.
You did experiment.
Yes, yes. And there are limits. Everything has limits. So when you go to like do some action on your S3 bucket, list objects, put whatever, all of those actions have limitations. And so if you talk to your service support person, they might be able to tell you what is your limit? How many transactions per second on that particular action? And when you partition, so let's say I do a lot of writes, I might be doing hundreds of transactions per second. So it's like causing me a failure in that particular second. It doesn't cause me a failure all the time. It's just kind of throttling me in that particular second when it's partitioning. But after the partition, or after the repartitioning happens, the next time I try to write, it works great because it's repartitioned. I've got more partitions, and so the parallelism is more efficient. Cool. Well, I'll be around later. Thanks so much. This is great.
Thank you, Anya. That was great.